All right, welcome back, class. This is 9.2b, and this is now on compound interest. So, interest, there's going to be two different things going on here. Where is my cursor? Oh my gosh, I lost it. There it is. So, the first one is when money is received from a bank for having money in a savings account. So, in that sense, you're getting a positive investment. You're earning money. The other one is extra money you pay when you owe someone money. So, this is like college tuition or something. So that's negative. You owe, you're not earning money off that. Compound interest is when you collect or are earning money on a regular schedule. And the schedule can be as follows down here with these examples. So during a year, you can get annually, so that's once a year. And then otherwise, you can get these other ways to earn money when you put it into a bank. So you can earn it monthly, weekly, and daily. And so these will then be what we can plug into, well, this equation right here actually, to solve and find out how much money you can earn in a year by keeping it in a bank. So some things have changed. A is now your total amount. P, where it was A in the last equation, P is here. This is now your starting amount. R, that's your rate again, so the decimal, the percent. And then I guess I could just highlight A is your total amount, P is going to be your starting amount, T again is the number of years, and now a new one here is N, the number of times compounded in 1 year. So that's these examples up here. It can be annually, in which case N would just be 1. So let's look at a couple examples of that. In this first example, it says you deposit $1,500 into an account. So that's your starting amount. That's your P. P is 1,500. That pays 6% annual interest. So right there, that's your percent. That's your rate is 6%. Find the balance after 1 year if the interest is compounded. So after 1 year is your time in years, 1 year. And finally, we need to know what our N is in each case. So in the first case, it says N is annual, so that would be when N was 1. If it's quarterly, I hope that's intuitive, where quarterly would be 4 times a year. And then daily, how many times a year? That'd be 365 times a year. So let's find out our A. Let's find out how much money we'll have in each case at the end of a year. So we're trying to find out what A is. So we're going to plug in P, R, T, and N into our equation to solve. So we have P, which is 1,500, times 1 plus R, which is 0.06, over N, N is 1 in this case, to the NT power. Again, N is 1, and then T is 1. So we can simplify using our order of operations. The order of operations, or PEMDAS, we're going to want to do what's inside the parentheses first. So we'll need to divide first. So that'll be 1 plus 0.06 divided by 1 is the same as 0.06 to the first power. So then we have A equals 1,500 times. Now we can add inside the parentheses. 1 plus 0.06 is 1.06. I hope you also notice that this is going to be growth. That's why you're earning to the first power. Now we can actually find the product, because anything to the first power is going to be just itself. So we can do 1,500, that's a 0, times 1.06, which actually I've already done. Let's see here. 1,500 times 1.06 is $1,590. So after a year with annual, let's see, compounded interest that's annual, you're going to earn now, you have 1,590 when you started with 1,500. So that's nice. You're making some money. Let's see what the change will be for quarterly and then daily. So the only change in the equation is going to be our N. Everything else is going to remain the same. So what is N? 4, and that goes in the denominator right here and then up in the exponent. So A equals 1,500 times 1 plus 0.06 over, so this is where it changes, now it's 4, because that's my N, to the 4 times 1 power, because it's N times T, and N is 4, and then t is 1. So we can simplify again. Same way, order of operations. 1 plus, so we need to find out what this quotient is. I have already found it actually. It's 0.15 to the 4th power. We can simplify that product in the exponent. Now we can add our like terms here in the parentheses. So that's 1.015 to the 4th power. So now, order of operations, we need to take our exponent. So this base to the exponent, it'll be 1500 times, let's see what I got, 1.06136. Now we can find out what this product is. 1500 times this number, and we get 1592, and then 5 cents is what we have. So if you look, it's not much, but that is an increase. In this case, which was annual, we earned $1,590. Now we've earned $2.05 more. So, I mean, listen, when you put money in, you want the greatest yield. So that's not a bad thing to notice. All right, and now let's see when we do it 365 times, or a daily compounded interest. A equals, again, 1500 will remain the same. 1 plus your rate of 6% is the same. Now, n is 365, so that changes. And then we also have 365 times 1 in the exponent. So we can simplify some of this down. This fraction here, let me check, is going to be plus 0.0. What did I get? 6183 to the 365th power, because that's just 365 times 1. So A equals 1500 times 1.06183. When I add my like terms here to that power, so my next step, since my parentheses is simplified, exponent is next in PEMDAS. So then that becomes, let's see here. What did I miss? Oh, shoot. So this was my number after I already took the exponent. So that would mean this simplified not like that. We're going to erase all of this. So let me just walk you through. This would have simplified to that power, 365. That simplifies to this. Then it's a product here. So if you want, you can verify each step. Your end number, your final answer here should be $1,592.75. So verify that on your own and check it. That would be smart, just so you're clear on what the steps or order of operations would be. And then if you compare them, you'll notice that they increase each time from annual to quarterly to daily. And it isn't much each time. It's the growth rate is actually less, I suppose, but this would yield the highest return. And that's what you want, because it's your money. In this case, I'm just going to do the monthly here, but let's still go through what each variable is. So P, again, what is P? That's your starting amount. You deposit $800 into an account. So you deposited $800. That's your starting amount. The rate is your percent. That pays you 4% annual interest. Okay, so right there, 4%. So that's good to know. And we want it as a decimal. Find the balance, what's our T, after 2 years. That's now T, if the interest is compounded. So in each case, N would be 1, because that's annual. Quarterly means 4. And then monthly, how many months are in a year? That'd be 12. And I'm just going to do monthly here. So let's plug them into the equation and find out what our total amount at the end is going to be. So we have A equals 800 times 1 plus, now it's R over N. What is R? 0.04 over N is now 12 to the N times T power. N is 12 times T, which is 2. So now we can simplify again. A equals 800 times, I suppose I could do this, 0.04 divided by 12, 0.04 divided by 12. So really small there, I'm going to round 0.0033, 1 plus 0.0033. This becomes the 24th power, and then I can combine like terms in the parentheses here. So now we have to take our exponent. So that would be 800 times, let's see what I got, 1.08314. And then we can find out what this product is, and that's our total amount at the end, $866.51. These two for the total answer would be, this would be $865.28. And then this one would be $866.29. So again, as n increases, my total number at the end is going to increase. You check all three of these, see if you get the same number, because that's good practice. Okay, now, this is a different equation here, and there's a keyword at the very beginning. It says compound interest formula when compounding continuously. So keep that in mind. We're going to use this equation when it's continuously. As of right now, I'm not 100% sure if you'll get the formula on your exam, but I'm pretty sure you will. So, but it's still good to notice that if it says continuously, we'll be using this equation. It says A equals P times E to the RT power. A good way to remember it is PERT. So continuously means PERT. P times E to the RT, I guess, is just a quick way to say it. And then we can go through again some similar variables. A is the total amount. R is the interest rate as a decimal. P is your starting amount again. But okay, this one, E is a number. This is not a variable. You won't be substituting anything in. E is a number. It's irrational. It's like pi. The symbol for pi is like this, which represents 3.1415 ... So E is the same number. It's, well, not the same number. It's irrational like pi. E just represents this irrational number. And then T again is the number of years. So when we are compounding interest continuously, we're going to use this formula. So let's go through it. You deposit $500 into an account. So that's your starting amount again. That pays you 3% interest. What's the rate? It's 3%. Find the balance after 2 years. So T is 2 if the interest is compounded continuously. And we're not finding something to plug in for E, because I'm reminding you that E is a number. It's a number. So we can find out what our total amount is. So A equals P, so 500 times E raised to R times T in my exponent. R is 0.03 times 2, which is T. So we're going to want to take the exponent. On your calculator, you'll see E. Once you hit it, it'll give you the option to plug stuff in the exponent. So then we have A equals 500 times, once I take E to this power, it simplifies to 1.06184. And then we can take that product, and that will be my final or total amount. It'll be $530.92. So again, that compound interest was positive. You're making money, so that's not bad after 2 years. Let's check this one. You deposit $1,500. So my starting amount is $1,500 into an account that pays 4% interest. 0.04 is my interest rate. Find the balance after 3 years. So we can plug those in. I'm going to highlight just to be clear. P, R, and T are getting plugged in for P, R, and T. And E is a number on your calculator. Let's see if I can use the one off to the side with E. Let's see if it's anywhere here. There it is, I do see it. Okay, so A equals 1500 times E raised to the 0.04 times 3 power. So A equals 1500 times, I'm going to now do E to that power. If you notice, I want that over there actually. Oh, no. E is right here. And see, it gives me the option to now be in the exponent. And we said it was 0.03 times 3 because T was 3. So that's what that simplifies to. 1.094 is what I'll call it. 1.094, and then we can multiply that by 1500. So we can say times 1500. Oop, that's 1800. Ooh, there we go. Times 1500. And let's verify that is what I got. Ooh, it's close. How come that's a little different? So it's close to what I originally got. So I wonder what it rounded. A equals $1,641.26. And again, you should do this as well and see if you get the same answer. And I'm going to double check. Let me see what I got. 1,691. Okay, so I got 1,691 originally. So go through and check and see if you get the same thing. And I'm reiterating, when it says compounded continuously, you're going to use this formula of PERT. Do some association and try to remember it, but it will show up. You'll just need to know when to use it, like when it says continuously. And I believe that's it for this one. Yep. All right, so thanks for watching. Let me know if you have any questions, and I'll see you.